Thank you for joining me for this presentation. I'm Noah, and I'm a master's student in UNH. This paper is talking about faster and cheaper serverless computing on harvest resources. And let's first see what is serverless computing. Serverless computing is first developed by a company called Gimic, but is in 2006, but it's not really successful. And in 2014, Amazon Lambda was released, and it makes this this kind of service popular, and Microsoft started supporting this at 2016. And serverless computing is basically the developer submit functions to the server, and when the user need to call function, it start a request to the server, and the server returns a result. This makes the whole provides a black box for both developer and user. And in this, and in serverless computing, you only need to pay for the time you run this function and for the resources. So let's focus on let's say what the difference between serverless computing and regular computing. In serverless computing, developers only need to focus on functions, which makes it easier for developers to develop their application. The developer don't need to focus on applications, runtime, operating systems, or anything else. This has a good thing. It makes this service mostly cost effective, and the scalability is really good. And because the developer only need, and because the developer only need to focus on functions, it is more productivity for developers. And there's also some disadvantages. First, the performance. There is a vendor, and the vendor usually limited the resources you can use for each function run. And for the vendors, there's a important balance between performance and cost. Vendors want to give as best performance as they can to their clients, and want their service cost as possible. It's all about business. And speak of performance, the most important performance for serverless computing is the latency, because the user only start a request, and the server is only return a result. There's three main factors to affect this, the latency in serverless computing. First is that's from the starts from the bottom. The first one is execution time. About this one, there's nothing they can do about it, because functions are uploaded by independent developers, and Microsoft is definitely not an MPO. And another factor is queuing time. This is something we can do, but it's not actually really important, because in the real world, all servers tend to be light loaded. No one wants to use a overloaded server. So the queuing time, yeah, it matters, but as long as you have some kind of queuing algorithm to make the job distributed enough, it is okay. And the key factor for this kind of service is cold start rate. Cold start means the functions and resources are not in the memory, and you need to fetch it from the hard disk. And this takes time. This takes a lot of time. So the Microsoft guys, they noticed there's something called harvest resources, which makes virtual machines cheaper because it can use other resources. Just as this picture shows, the resources from harvest virtual machine can change during the time. It could be really small at the beginning, and it could grow bigger, and it could shrink, and it could also disappear. So what about serverless computing using harvest resources? Typically, functions don't consume a lot of resources. That's a good thing, which means fast serverless computing can easily adjust to how to harvest resources. And bad thing is many of function as a server functions can be packed on one virtual machine. That's it. This is because most functions are actually short functions. They don't take our resources. They don't run for a long time. So, and because of this, an evacuation of harvest resources may in fact more computations, and that can lead to a function run fail. But the good news is, for most harvest virtual machines, they usually don't change it within 10 minutes, and most functions can be finished in 30 seconds. This makes it long enough for a function to run on to finish running on a harvest virtual machine. So, and they also noticed that the well-known algorithm join the shortest queue, which is usually used on service computing, have some limits. It is pretty good at reducing queuing time for high-level systems, but as we mentioned, this doesn't really matter in a real serverless computation cloud. But in the same time, it could potentially increase cold start rate. This is something we want to avoid. And because it is joining the shortest queue, it do need to track the minimum queue size. And to do this, usually you need something at least log n. And they developed a new algorithm called minimum worker set, MWS. It can reduce cold start rate and it can reduce the queuing time. Yeah, but in some cases it may slightly imbalance the system, and it is just blindly integrating the everything, all the queues. So it takes a one time. Then they evaluated their algorithm versus the shortest queue algorithm, join the shortest queue algorithm, and the vanilla algorithm, which is by default of OpenWhisk. They tested they use all those functions to test the performance of those three algorithms. It's multiple Python, it's many Python serverless functions and from function bench. And they used they use OpenWhisk to evaluate all those 3 algorithms. And in the environment, they have 10 invokers, 32 CPUs, and 128 gigabytes memory for each invoker. But they are trying to simulate the serverless computing. So each CPU ranges from 5 to 25. They are not using all the CPUs, and it changed during the time. And we can see from this picture, the Vanilla is doing really bad, but their MWS is doing a pretty good job. And speaking of the co-star rate between the MWS and GSQ, their MWS algorithm is doing pretty good, but I don't understand why they stopped testing for GSQ here. Maybe it's just the system is overloaded, but it seems pretty good to me, at least where it ends. And this paper is about cost. It's also about, which means it's about money. So they tested the co-star rate against load for fixed bodies. The paper on the top left is actually about the fixed number of codes. And we can see from this picture, oh, by the way, the active means active changing harvest virtual machines. Normal means normal harvest virtual machines, and dedicated means a fixed virtual machine, a regular virtual machine. And we can tell from this picture, when the virtual machine, harvest virtual machine is actively changing, it's not doing really good. But when during the normal situation, it is doing almost the same with it performs almost the same with a dedicated virtual machine. And the picture on the top right is about it's a co-star rate against the load for fixed money. And all those lines means how many discount you can get. And in the baseline means how much it costs for what you can buy for a fixed body for and what you can buy under a fixed body for a dedicated virtual machine. And we can say because it is cheap, because harvest virtual machine is way cheaper, we can get more cores, we can get more virtual machines and more resources. And in their picture, we can tell the baseline is doing, I mean, it's not really doing good, but for the harvest virtual machines, it is doing pretty good. Even at the lowest discount, it gives you about 2 times performance comparing to the baseline. And for the best one, it's about 10 times. And they also evaluated the actual latency for each for dedicated virtual machine and harvest virtual machine. Also, it also seems pretty good at the beginning. There's no big difference, but as the requests start growing up, the dedicated virtual machine start working really soon. The latency is increasing rapidly, and in the best case, it gives performance roughly about 10 times better than the dedicated virtual machine. And come to the conclusion, this paper proposed to host serverless platforms on Harvest resources, and it qualified the changes of using Harvest resources for serverless computing. It demonstrated the reliability of hosting serverless workload on Harvest resources with trace gate-driven simulation, and it designed a harvesting where serverless load balancer on OpenWhisk. This is basically what this paper talking about. It's not actually a short paper, but it is mostly focusing on evaluation and introducing the serverless computing to Harvest virtual machines. Thank you.